amazing when you think about it. There's this invisible, silent force that powers, well, everything we rely on, right? Your phone, the lights in your city, the whole shebang. So what is this thing really? Well, today we're going to pull back the curtain and uncover the simple, elegant secret behind it all, the electric circuit. And our journey is going to start with something super simple, a flashlight. Yeah, I know, it seems kind of basic, but trust me, locked inside this everyday object is the key to understanding basically all modern tech. So let's ask the big question. How does it take a couple of little batteries and turn them into this powerful beam of light that cuts through the darkness?
Well, to find that answer, we're going to do what pretty much every curious kid has done at some point. We're going to take it apart. So let's pop open the casing and see what's really happening in there.
And, once you get it open, it's actually surprisingly simple. You've really only got two key parts. You've got the electric cells, that's our power source, and then you have the lamp, which is, our light source. These two right here, they're the main characters in our little electrical story. Okay, so let's start with character number 1, the power source. What is actually going on inside these little cylinders? I mean, how do they store all that energy that's eventually going to become light? So each one of these is what we call an electric cell. You can just think of it as its own little portable power pack. And every single one has two super important connection points, what we call terminals. You've got the positive end, that's usually the little metal cap, and the negative end, which is the flat disc on the bottom. These are like the in and out doors for all the energy that's just waiting to get out. Now, when you team up two or more of these cells, that's when you get what we all call a battery. But here's the catch, and it's a big one. You can't just toss them in there any old way. For the magic to happen, you've got to line them up in a very specific order. Positive end to negative end, positive to negative. It's this chain that creates a way more powerful, continuous flow of energy. All right, so we've got our power source figured out. Check. But now, how do we get that energy out of the battery and into the lamp to actually make some light? Well, the whole secret lies in creating a path. See, if you just take a wire and connect it from, say, one end of the battery to the lamp, well, nothing happens. It's a total dud. You've got a perfectly good cell, a perfectly good lamp, but without the right kind of connection, you get absolutely nothing. There's a really important piece of the puzzle missing here. But check this out. Watch what happens when you create a complete, unbroken loop. A path that starts at one terminal, goes through the lamp, and then travels all the way back to the other terminal. Boom! The lamp instantly glows. This complete path, this closed loop, that's it. That's the secret to the whole thing. And this complete path, it has a name, of course. We call it an electrical circuit. It's basically a highway that lets something called electric current flow. A great way to think about it is like water flowing through a pipe. This current leaves the positive end, travels through that tiny little wire inside the lamp, that's called the filament, which makes it heat up and glow, and then it flows all the way back to the negative end to complete the loop. No loop, no light. And get this, the direction of that flow isn't random at all. It's a fundamental rule. By convention, just so everyone's on the same page, we always say the current flows from the positive terminal, does its job, lighting the lamp, and then returns to the negative terminal. It is absolutely a one-way street. Okay, so if a circuit has to be a complete closed loop to work, how do we ever turn anything off? I mean, we don't have to yank the batteries out every single time, right? Of course not. And that's where the simple, absolute genius of the switch comes into play. A switch is really just a gatekeeper for the circuit. When it's in the off position, it creates a physical gap in the wire. Think of it like a raised drawbridge. The path is broken, so the current literally can't jump across the gap, and the light goes out. But then you flip it to on. The drawbridge lowers, it closes that gap, and suddenly the circuit is complete again. The current starts flowing, and the lamp lights up. So simple, right? But it's incredibly effective. Okay, let's recap. We've got a power source, we've got a lamp, and we've got a switch to control the whole thing. But what is that path, the wires, actually made of? Because it turns out the materials we use are just as important as any of the other parts. I mean, just think about any electrical cord you've ever looked at. Why is it always a metal wire on the inside, but then it's covered in plastic or rubber on the outside? There is a really, really good reason for that design, and it all comes down to two very different types of materials. It's actually pretty simple. Some materials, which we call conductors, let electric current flow through them super easily. Metals are perfect examples. Think copper, aluminum, even a metal key. But then you have other materials called insulators, and they do the exact opposite. They block the flow of current completely. Things like plastic, rubber, wood, they are fantastic at stopping electricity in its tracks. And that is exactly why wires are designed the way they are. We use a conductor, like copper, to create that electrical highway. And then we wrap that highway in an insulator, like plastic, to make sure the electricity stays safely on the road and doesn't, zap us. You absolutely need both to make any electrical device work safely and effectively. Now, obviously, circuits can get a whole lot more complex than what's in our simple little flashlight, and trying to draw them all out would be a nightmare. That's why engineers came up with a universal shorthand. So instead of drawing a realistic-looking battery and a lamp, they use these simple standard symbols to create something called a circuit diagram. It's like the universal language, a blueprint for electricity that an engineer anywhere in the world can look at and understand immediately. So there you have it, the simple secret tucked away inside a common flashlight. It's just a power source, a path, and something to power, all connected in one elegant closed loop. Now take a second and just look around you. Your computer, the lights in your room, the phone in your pocket, every single one of them runs on countless unbelievably complex versions of this exact same principle. And that leaves us with one last kind of mind-blowing question. Just how many of these invisible electrical highways are humming away, powering your world right this very second?